Welcome to Unit 3, Lesson 3, Practice Problems, Graphs of Rational Functions, Part 2. So, rewrite the rational function in the form of c plus r of x, where c and r are constants. So what that means is that we had to separate the fraction. So what you're going to do is take x minus 4 over x, separate this into x over x minus 4 over x. X divided by x is 1. This is minus 4 over x. So, as x gets bigger, this will go to 0. So this becomes your horizontal asymptote. The vertical asymptote, so let's write this down. To find the vertical asymptote, I should probably put a colon there, set the denominator to 0. Set it equal to 0. I should probably put equal to in there. Now, let's do this in a different color because this is different. To find the horizontal asymptote, separate the fraction and look for the remainder. Now, in this lesson, we are going to get constant. So when y equals a constant, if this is our remainder, 1, then you get a horizontal asymptote. So for this lesson, we're going to get horizontal asymptotes because our remainders are going to be constants. Okay, average cost in dollars per mile for riding X mile in a ride share vehicle where this. So this is an average because we have X as the denominator. So vertical asymptote, set the denominator equal to 0. So X equals to 0. This is your vertical asymptote right on the y-axis. All right, so now for the horizontal asymptote, I should probably do that in a different color. Let's do that in a different color. Horizontal asymptote, we're going to do 2.5 over x plus 2 over x over x. Now, as x goes larger, this goes to 0. X divided by x becomes 2. So your horizontal asymptote occurs when y equals 2. And we have to remember, on graphs, when x equals a constant, you get a vertical line. When y equals a constant, you get a horizontal line. So if this was our x and y axis, if this was x and this was y, our horizontal asymptote is on the y axis because x equals 0 is this line. And then y equals 0. Y equals 2. Y does not equal 0. Y equals 2 is this line. That should be a dotted line. Up 2. 2 is above. I'm sorry. I put the things in the wrong spot. 2 is above x. I'm sorry, not negative 2, positive 2. So this gets erased. and this would be x, and this would be 2, y equals 2. So in the context of the situation, we have the number getting closer to $2. So the average cost in a rideshare vehicle is $2. As the miles get very large, it goes down to $2. All right, the graph of two rational functions is shown. So what we're going to have to do is the dotted line will not show up on a calculator. You will see the graph, but you will not see the dotted line on the calculator. The dotted line is there to show you the horizontal asymptote. Separate your fraction. As x gets bigger, that one goes to 0. X cancels out x. -3 is your horizontal asymptote. So this is the graph when y equals -3. So y equals -3. Okay, this is from a previous lesson, so let's talk about it. Which polynomial function is here? So we got x equals -1. These are our intercepts, x equals 2 and x equals 5. To make an intercept a factor, you had to switch the sign. So x plus 1 x minus 2 and x minus 5. So which one is x plus 2, x minus 2, x minus 5? That would make B the correct answer. Okay, and behavior is coming back around again, so let's talk about end behavior. State the degree and end behavior of the function. So you look for the highest exponent, which is 4. We take the whole term, -2. The sign in front of the term goes with the term. A negative x even makes a parabola. That's a U-shaped graph. Negative means it goes down. So basically, here's your y-intercept. So if we was to roughly sketch a graph, it comes through at +7. We don't know if it has multiplicity or not. We don't know the zeros, so we're not concerned with that. So it does something like this. Something like that. I don't know. You can graph it and get more exact, but just something like that. All we're worried about on end behavior is where the thing winds up. Both ends are down. When it's even, both ends go to the same place. The negative out front tells us it goes down. Okay, so now on this one, they're asking us to find the vertical asymptote. How do we know they're asking us to find the vertical asymptote? Because the dotted lines are vertical this time. These functions have a vertical and a horizontal asymptote. We could find both. I think you could look at the graph and tell, but let's see. All right, so first things. So for vertical asymptotes, set the denominator equal to 0. X minus 3 equal to 0. You add 3 to both sides. So x equals 3. That makes the first graph. This graph right here. Okay, that's for the vertical asymptote. Set the denominator to 0. That's easy. It will get more complicated soon. But now let's look at the horizontal asymptote. The horizontal asymptote because you do not have an expression in the top, we take our 10 over x minus 3. Basically, as x gets really, really large, this thing goes to 0, and our horizontal asymptote is at y equals 0. Remember, an asymptote is a line a graph does not touch or cross. So our Horizontal asymptote actually occurs when y equals 0. And when we're talking about x getting large, we're talking about like x at 1,000,000. So 1,000,000 minus 3 is like 999,997. So if you do 10 divided by that, you're going to get a really small number. Thank you for watching this video. I will see you in class.